John, how can you always have the right TV for the right application without carrying hundreds of valves on your truck?
You can carry the hundreds of valves on a trailer behind your truck.
That's too funny. That would work, but how are you going to do that? Maybe there's an easier way.
You can use Sporland's interchangeable cartridge style Type Q and Type BQ TEVs. Type Q is a conventional design, and Type BQ is a balanced for TEV.
Well, come on. I need easy. How easy is it?
Easy as 1, 2, 3.
And it serves thousands of unique applications. So what's the process? How do I put this together?
First, you select the thermostatic element assembly. Then you select the body that you need. Then you select the right size cartridge for the application to get the proper capacity TEV for your application. And then I guess it should also be said you want to actually assemble those into a single valve.
That'd probably be a good idea. These easy to select and assemble valves mean you're always carrying the right valve for the right job. Then, if the folks want to learn more, what do?
You can go to sporland.com and find more information on the Type Q and BQ thermostatic expansion valves.
I guess that's Jim and John for Sporland signing off.
We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporland, Carlisle compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann parts, and K2Therm. United Refrigeration, Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live-to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration, Inc. has all your solutions down cold.
Yeah, I know. Hey, good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're here with your hosts, Brett Wetzel and Kevin Compass. What's going on, buddy?
Oh, just kind of like trying to coast through the week and not have anything explode in my face.
Why are you home early?
We're like out of work. Not really like, I don't know. I start early, but like we're kind of like out of work.
You're ramping down the job that you're working on?
Well, I finished a Danfoss changeover. I did some 255s to 880s, which went incredibly well.
Yeah.
Still nervous about it
Gotcha.
because things don't usually go that good.
Yeah.
So something's usually around the corner just to give you a swift kick right to the nuts. But
I want to call Dave. I want to figure out, because I was talking to someone. I like the calculations, but I wish you could do more.
Yes.
And I was talking to someone and they said that you can do a lead lag, like with like a VFD setup, but I'd like to see what the hell that would look like in a Danfoss calculation.
it'd probably be like 30 of them.
Well, that's what I'm saying. There's a lot of lines that would have to be involved, right?
Yeah, I mean, it would be extremely difficult to troubleshoot.
Yeah.
I mean,
that's why I'm kind of curious, because if it does exist, I want to see it, because I know what it can look like, and then with E2 and shit, like with the Flexi, but like I don't know.
or some block logic, it's even like easier.
Yeah, for sure.
With RDM, they have lead lag blocks.
Yeah.
I mean,
Yeah. I don't know.
yeah, I don't know. I just been doing control stuff this week, and then a little bit of light service, and
What do you do? Where are you going next week? You going anywhere?
no, well, we're doing a CO2 startup at Target,
Cool.
so
Close, or you gotta travel?
it's like an hour and a half. It's a super Target switch over, so roof hatch on the opposite side of the building of the rack.
Is it in the front of the building?
Yeah,
That
it's
sucks.
the only super Target I've ever seen with a roof hatch in the front of the building.
I just had this conversation. So like if you notice, a lot of the stores with the same vintage number basically are like designed the same way. So like if you have like any of the 1700 series stores, they're almost fucking identical. Same thing with the 2100 series stores and shit like that. But like
Yeah.
I've seen a couple of them where the roof hatch, you walk in the building, it's all the way in the front, but the rack and all the equipment's on the roof all the way in the back.
Yeah, this store was the worst to service because like the condensers were the only thing we had to really get to in the roof, but like the water spigot was in the front of the building.
Gotcha.
Well, and the condensers were on the back side of the building.
Hmm.
You needed like 600 feet of hose.
Yeah, that kind of sucks.
So I don't know. There'll be a lift up there for construction, but it's servicing is this thing is going to suck because you're going to be walking all the way across the roof.
So they need to just move the damn hatch. But
I mean, putting a hatch, like I never understood that. Like it's gotta if you look in the long run, there's no way within a year or two that wouldn't pay for itself. It can't be more than $3,000 to move a roof hatch. $4,000. I mean, you figure all the wasted hours of like carrying shit all the way to the front of the building, then all the way across the roof, then all the way back.
no, I totally get it.
Not to mention the liability of slipping and falling in the wintertime because we all know they got white roofs.
I hate white roofs.
Yeah.
Wow, worse than that is the other one that we all love that has the metal roof. That
Oh
you have
yeah.
to walk diagonally in order like
I fell so hard on one of those in December. Like I literally watched my soul leave my body.
you had your little Vito bag and it went up in the air and like all your tools like it looked like a Christmas story when the kid fucking lost all the lug nuts. All your tools are flying back down to you. It's so low.
No, I had my Vito bag that I use for like project work. Like it's got
Oh.
all my tools in it, so it's like
Yeah.
it's like 48 pounds. I watched that thing come down right on top of me. It was like, oh, I'm falling, and then it's like, oh shit. just to knock the wind out of you the second time.
Did it happen in the slow-mo?
Yeah, it always does.
See, I've only had that happen, I think, twice. One when I was closing a roof edge and stupidly I wasn't didn't have one hand on there. So when I went to go pull the roof edge down, the little rubber handle that's on there slipped off because it was raining, and I dropped straight down about 15 or 18 feet, and I landed straight leg, and that's when I think I officially fucked up my back. But that, yeah, that was kind of gnarly. And one time when I was probably about 14, I was riding a spoked bicycle and I was going down this hill really, really fast, had my sweatshirt tied up in the front, and you just saw it go right in the front. And like, as soon as it got sucked in, everything then sped up, and then I just went over the handlebars really, really quick. But tonight, hey, we're talking about VFD control on compressors. Certain things that you're going to have to watch out for when actually controlling a compressor with a VFD. They have a range depending on the manufacturer. What is it's or whether they 28 to what 87 hertz or something like that.
No, it depends on the compressor model number. So you got to look it up because some compressors are 25 hertz, some are 30 hertz, you can go to 60 hertz. The only ones I think they can go to 87. I mean, I may be wrong. The only ones I think can go to 87 are those Speed compressors,
The
which
one where you actually have the VFD connected to the back of it. You need that.
I refuse to run them that high.
That scares me.
If you put them at 60 hertz, they're fine.
Yeah. I guess
And-
they're just trying to get a little bit more capacity out of that. Just stretch it just a little bit.
I mean, yeah. I mean, let's be honest. Like a little bit of flood back at 60 hertz isn't good. A little bit of flood back at 87 hertz really isn't good.
A little bit of floodback at 28 hertz is really bad.
Yeah. I would imagine at 87, it's got to be a little bit worse though.
Got a
You'll
little
get
bit more heat.
a little bit more smackdown on that rod, a little more torque to it. It's got a little bit more like, oomph to it before it comes to that dead halt.
Yeah.
But yeah, I mean, everybody's compressors are different, guys. Well, look, I mean, Carlisle has a spec for their compressors, Copeland has a spec for their compressors, but they all say the same thing. Like everybody I've looked at has been no unloaders on the variable speed compressor. So they don't want you to have an unloading head on there too. I'm assuming because that's going to be even less mass flow going to it. And I would assume it would also make it unbalanced somehow.
Yeah. I'm looking. I know I have the specs somewhere because I literally just used this.
I mean, everybody has one. I mean, Copeland is 25 to 30 hertz, and then it's 60 hertz max.
Whoa. Are you sure it's not 28
Yeah,
for
I'm
Copeland?
positive.
Oh, okay. Sure.
It's 25 to 30, depending on which compressor it is. Now, with Carlisle, same thing. Like they get really. It's important to know what model number compressor you're looking at. A variable speed is the only way you could unload or have capacity control with a like Carlisle. Yeah, those.
You go dead?
Yeah, it's my brain is with a compound cooler. So yeah, a VFD is the only way you could control capacity with a compound cooling compressor.
Yeah. Yeah. Because I guess, yeah, because you really couldn't control. Yeah, that wouldn't work too well if you tried with unloaders.
Yeah, you can't. There's no way to unload it because of the way the compressor is internal set up. So, but what you can do is use a VFD, and it actually works fairly well.
Yeah.
Is using a VFD to control it.
I've
Now,
never seen one on there.
actually, Walmart's got a couple stores up here with them.
Never seen it.
Yeah, slap some Danfoss drives on there, which I don't know. Danfoss makes a hell of a drive. It's pretty hard to compete with that. That's got to be one of their best products. I mean, that is a solid drive, and it is extremely easy to set up for compressors. The other thing is, when you're setting these up, make sure you follow the VFD and the compressor manufacturer's recommendations for it because there are different torque characteristics. So a compressor is a constant torque load. A fan or a pump is a variable torque load. So a constant torque load, like if it doesn't have a certain amount of torque, it'll stall out. It'll stall the shaft because it has that resistance against it. Like a fan motor or a pump will still keep spinning as the torque reduces. But a compressor is a constant torque load. So you need to make sure. I've seen this a lot, like on startups, guys will just program it and they won't pay attention. Well, most VFDs come out set up already for variable torque, meaning if it's a pump, if it's a fan, because it's most applications for it, you need to set it to a constant torque. It has to be a constant torque load. Okay. And the other thing is your startup amperage is going to be higher. So you need to have that startup amperage set up higher so that you get that inrush and lets that compressor start. And then you go from there. And then you could have your ramp up and ramp down. Also, your ramp up and ramp down times, a lot of times, like they're at 30 seconds for a fan or a pump. We got to be like anywhere from 3 to 5 seconds max for ramp up or ramp down, or you're going to get shaft stall. Go ahead, Brad.
Yeah, so I'm looking at the set points that they have for the transcritical and subcritical CO2 compressors for Bitzer. And their recommended settings is a 3-second accel and decel time. Because I've seen it where like they'll put for the accel time, they'll put something, I don't know, 60 seconds or whatever, or 30 seconds. And then basically the unit goes up to like 15 hertz over amps because like you're exactly what you're describing, where it torque stalls. It basically causes such a high amperage and then it goes off on limiting and then doesn't allow the thing to fully rotate. So you can't have that cell too high, otherwise you won't be able to get up to the speed what you need before it ends up going on high amperage.
Correct. And then also like the current limiting, you need to crank that thing up as much as you can, possibly on that drive. So that way when it does go to start, it doesn't get that inrush of like that, even that 3-second stall, like is enough sometimes if the current limiting's not high enough. Like I think the Danfoss drives, like some of the racks I've seen, like we've done is like 200%. But it's for so many seconds but it needs that to get that initial start. And once it gets it, it's fine. But it needs it to get that initial start. The other thing is when you guys are doing these is make sure that like everything's programmed before, make sure it's set up for a compressor, make sure all your amperages are in there. And then when you're go ahead, Brett.
I was just gonna say, make sure your voltage is correct. And I'm gonna state this because I've seen it now happen twice. Any VFD that might be mod bust into any kind of energy management system, don't assume that the settings haven't been changed or haven't been messed with. We've now found this at least twice where that we go there for a service call, the unit's going into bypass. It tries to go in bypass, but it's off on thermal overload. And basically what was happening was the voltage somehow, instead of being 460, automatic was programmed to 230, caused a situation where it looked like it was under lock rotor amps. Technician replaced the compressor, still fucked up, finds out finally that the voltage was changed by someone else. And now all of a sudden you look like an ass because you just replaced the compressor for no damn reason.
Yeah, that's not fun.
Nope. Not at all.
The next thing is making sure that like all your parameters are in there and they're all correct, and then write them down inside the cover of the drive. Like you usually don't have to change a ton. Usually it's like 13 or 14 parameters. Write them all down inside of a drive, what they were and what you had them change to. And then the second thing you want to do is you want to lock the keypad. You do not want to be able to ramp that compressor up from the keypad. I've seen this like time and time again is they'll install a VFD or like on startup, the VFD put in, the manufacturer won't lock the keypad. And then when somebody goes there, they're ramping it up and down by hand. Like if it's got a run enable signal from the E2 or whatever, and they got this thing in hand, you could fuck this compressor all up because in hand, you're not going to be able to ramp it up fast enough. And then if it is, you could bypass safeties depending on what it has. Because
Well, I mean, unless it's running already. If you have it running already and adjusting the frequency,
I mean, that's one thing, but like if you have that thing running in hand and you're ramping it up and down, it'll run without a run enable. So, I mean, there's nothing to stop it then if there's no VFD contactor. Because a lot of these like racks that are coming out, they're skimping out on the bypasses and just putting just a VFD straight in for one compressor. And if it goes down, it goes down. There's no backup.
Mhm.
So, I mean, you could run a compressor without oil. You could run it with no head pressure safeties. So just be aware of that. Now, one big thing, which I'm going to talk about, and it's related to CO2 and DX, is harmonic induced vibrations.
Oh no.
So this is a huge problem, especially with all these CO2 racks that are coming out. Like, I mean, you're seeing it more and more. So at certain frequencies, under certain conditions, that VFD compressor will shake like a Model T going down a dirt road. It'll only be under a certain frequency that it'll do it. Now, every drive I've seen, I can't speak for B because I really haven't messed with those too much. But like Dean Voss, Emerson, all those other drives, they have the ability inside the drive to skip frequencies. So if you find a frequency, like say you're going through it, like usually like 42 to 45 hertz with the Bitzers on CO2, they shake like a Model T and they break lines and they run like shit. So what we end up doing is I do it on startup no matter what now. I just delete 42 to 45 hertz out of the drive. I don't even want to hear it run because I've had so many do it. So, and it never does it when I'm there the first time and it ends up breaking a line. So I just delete the frequencies out and I will run that drive in hand. I'll keep an eye on it. I will run that drive in hand at like subcritical, like 700 pounds with a decent section. And I will go one click at a time. It takes like 20 minutes for me to do it all the way through, all the way from 25 hertz to 60 hertz. And then see if it vibrates. You'll find it. You'll know. And then I'll force it into transcritical mode. I'll get that rack to like 1,300 pounds and I'll do it again because sometimes you'll have more bearing induced frequencies when you're running in transcritical mode, higher pressure. It changes a little bit. So like sometimes it'll be 45 to 46 hertz and then you may get 31 to 36 hertz or 31 to 33 hertz that it starts shaking violently. And I mean, it's violent. Like it'll shake the whole rack. It'll wear out cush clamps in weeks.
Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westmeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode. I'm sorry, I was looking at it. I'm pretty sure that you can skip frequencies in the ABB.
I'm sure you can. I mean, I think it's a common problem with drives. So I'm pretty sure every manufacturer drives. I mean, the Yokosuka ones or Yokosuka or however to say it, like even those ones,
Yes,
even those drives you could skip frequencies in. So like, I mean, just about every single drive you could do it on. So that's just one very important thing that you're setting up a VFD compressor. Now, even on DX, like normal, like 448, R22, it's the same thing happens. I mean, it's a very overlooked thing when you're installing a VFD or starting up racks of VFDs. I mean, and you're going to start seeing this a lot more. I mean, the prices of VFDs have come down a lot. So I mean, you're going to start seeing them on racks a lot more than digitals. I mean, digitals are nice, but I mean, VFDs are you'll way smoother control if they're tuned properly. So we go ahead, Brett.
No, I was just gonna say, so you run it in transcritical and subcriticals just to make sure that you can find, what it's gonna do. The other thing, that you can do is make sure all the compressors are really running at the same direction. Because here's the thing, like you can have all your compressors that are hooked up to straight three phase work all different ways, right? And having them not all go the same way could potentially cause some sort of vibration in that machinery. So just be mindful of that. And sometimes you don't really find that, you don't really see that until a couple years down the line when a couple pumps have been replaced and you guys are switching wires and stuff over in the pecker head or whatever. So just be mindful of that. I mean, some technicians have a three-phase rotation indicator where it has a little wheel on there. You hook it all three phases up and you can actually see the rotation of which way it's going to be turning. So everything is going in the correct direction.
Be very careful with those because some of those are not rated for voltage.
What? No, I mean, one I have.
But I'm just saying, like, be very careful because, like, some of those are rated just for you. They'll hook it up to a motor and see which way it's turning. Like, some of them aren't rated for 460. Like, you got to be real careful with those. Don't buy a cheap rotation tester, like buy Fluke or something. Something you don't want to explode in your face.
100%.
So the next thing I want to talk about is scroll compressors. Scroll compressors get a little weird with VFDs. So most scroll compressors, you're very limited on what you could do with the VFD. So I believe Copeland's thing is 45% is all you can go down to. So with a externally mounted scroll, now they have come out with like ZB scrolls now that are variable speed. Like they've changed some stuff on that, but like the older scrolls that they had, it was 45%. So, I mean, you don't get a lot of modulation out of it. It's better than nothing, especially if you have a rack with no digitals. It's better than nothing. But, I mean, doing VFDs on a scroll really doesn't make as much sense because that bottom bearing and everything in there is how you're moving oil up through the scroll set. It's slinging it. So as you reduce that, I mean, it reduces your oil your ability to sling the oil up on top of the compressor. So, I mean, it's not as efficient. So you're better off in a scroll using a digital. I know Bitzer's got some different stuff where they've gone a little bit lower, but for the most part, like, I don't see a lot of variable speed scrolls. I think I don't think those Emerson ones that they were showing were digitals. I think those are just straight variable speed, but I think those are all completely different. So they redesigned. Which is interesting is supposedly Bitzer has a digital CO2 compressor.
Scroll.
No recip. They're using a digital now for the TC side instead of a variable speed,
Mhm.
which I'm 50-50 about because I mean that's going to make the suction pressure jumpy, and jumpy suction pressure with case controllers is not a good thing.
No, you want to try to keep it solid as possible as far as your suction pressure because it just keeps a smoother operation. That's the whole reason why, like in CO2, we try to tune that flash tank just to maintain. Because the more you maintain your flash tank, the more smoother that BGV is opening, the more the load is going to be more solid going on those compressors, which isn't going to cause those up and down.
Correct.
with CO2.
You're basically introducing the up and downs, from the beginning. I mean, with the digital. I mean, digitals have their places. Don't get me wrong. I love digital compressors, but I mean, I'll take a VFD compressor all day long over it. Now, when we get to the E2 or like Danfoss, and you're controlling this actual compressor, say you're setting it to 10 to 0 or 0 to 10 volt signal. Now, ramp up or ramp down times. So I don't know why guys do it. Like I see it all the time, like across all kinds of customers. You see ramp up and ramp downs at like 2,000% or 2,000. Like I think that controls like shit. I like to have my ramp ups like 500, 550. I would take a slower ramp up and a slightly faster ramp down than anything. I don't want to spool up that compressor and just to slam it back down. I would rather ramp up slower so it could catch up to the PID than let it slam up real quick and just instantly ramp up to full speed. And then it overshoots that point and instantly ramps down. I want to keep that compressor running steady. So I want to try to keep the ramp up and ramp downs from that happening. So with me, I like slower ramp ups and faster ramp downs. So that way we don't overshoot set point and it just holds it a lot better. You don't want this constant hunting. If that thing is all over the place, it's not good for the compressor. It's just like cycling. You're gonna eventually wear it out. I mean, or you're gonna wear out the drive. So you want to make sure that compressor is not just hunting all over the place, but you also want to be able to have it where it will maintain the suction group if need be. The second thing is let's go into drive maintenance. So guys, drives are just like everything else. They need maintenance. You need to go through and you need to tighten up all the connections on the high voltage and the outgoing voltage. Now, when you do this and you power down this drive, you need to let it sit till it's completely dead and then give it a few more minutes because there are large capacitors inside this drive and they're charged up. And now it has a resistor in there that it's decharging the capacitors with. You got to give it some time. You don't want to go grabbing the voltage leads of that or like the DC bus and that thing's still charged up because it will light you up like a Christmas tree. I mean, there is large capacitors in there that hold a lot of power. So you need to let that thing completely die down before you go and try to do anything with it, whether it be on the compressor or on the drive itself, because you want to let that resistor bleed down that drive so that way you can service it properly without getting electrocuted. Now,
Sorry.
go, Brett.
I was just going to recommend if you do have a bypass, also remember, do not push in those contactors at the same damn time. If you do have a bypass, remember that basically what that's doing is instead of having the voltage go through the drive and then be converted to a DC sine wave, it's going to bypass the AC straight to the compressor and thinking that the drive might be bad. If you were to actually have both those contactors engaged at the same time, you would introduce AC and DC at the same time, and you would have a very, very bad day. So that's why a lot of the controls, they do have a wired in interlock, which does not allow both those contactors to be on at the same time.
Yeah, I did a startup and one of the manufacturers that does not do that wired in the control boards incorrectly and didn't follow the pop sheet and was on a relay. The bypass was on a relay for a compressor,
Oh no.
and the drive was on and energized and running, and that compressor contactor hit, or the compressor relay hit, and all of a sudden we're up there, boom, whole fucking VFD explodes.
Yeah, you'd have a bad time.
Yeah, it's just like, whoa, what happened? Like you're looking, oh wow,
Damn.
this was not interlocked.
No, I guess not. So make sure you check that upon startup, preferably without voltage. That way you can make sure that the contactors, if one's pulled in, the other one's gonna pull right out.
Yeah, I mean, don't ever. I mean, that's a quick way to blow up the IGBTs. So the other thing with like drive maintenance, guys, is there's a cooling fan in there. Okay, well, there's also cooling fins in there. So especially if you get these larger drives, like these Aldis, where they got the 70 horsepower medium temp drives, so you need to clean those. So what needs to get done on PMs when you're up there doing the PM is take some CO2 and from the bottom, shut the drive off. From the bottom of it, not through the fan, through the opposite side, blow it out with CO2. Blow out the fins on the bottom. It's got like cooling fins in there. They load up with dust. As that drive loads up with dust, it's going to heat up. As it heats up, it's going to get less efficient, and it's going to cause it to break down. Heat kills electrical components.
In anything, right?
Yeah. So I mean, blow the thing out. Now, after it's been running for a few years, what I found is like ice machine cleaning brushes, like burner brushes, I think they call them. They look like a Christmas tree almost. Like it's a long brush with like it starts skinny at the top, it gets fatter. Shove that up and down in there, like you're cleaning the flue, like you're cleaning out the fins, and it'll knock all that crap off in there, and then you blow it out, and everything's good. Now, if you have a drive that's going off on high temp, that would be my first thing after I check to make sure the little fan was going, little muffin fan was going. Now, if you lose one of those and it's a weekend, I usually have some of those little axial fan motors in my truck, the little muffin fans for cases, because we have some cases around here that use them. I'll throw one of those up there and just self-tap it or double sticky sided tape it to the top of the drive, so that way I can blow air through the drive and keep it running. Because it is essential that compressor runs. It makes everything run smoother. So you can keep it running that way until you get a new fan motor from Danfoss or ABB or Emerson. I mean, it may be a little while, but one of those fans will work in a pinch.
I've seen a guy take just a regular Ryobi fan that comes in the kit and just turn down, just have it plugged into the wall, and just that's what saved it for the Sutton blade until we got that fucking axial fan.
Yeah, I mean, whatever you're doing, you just got to get some air moving through that drive, keep it cooled off. That's just all you need to do. And then the next thing is torquing down like connections. Make sure connections are good, tight. Use a torque wrench. Use a torquing screwdriver. Whatever you got to do, don't just muscle on it. Now, I'm a big proponent of this. A lot of guys aren't. When I go to check tightness of something, I never tighten it. I always loosen it. Because how are you going to know how tight something is unless you loosen it first?
True.
So I'll do that. I'll loosen it first and then retighten it to make sure that see how loose it was. And then thermal imager. If you got one, great. Makes a great way to troubleshoot drives. All right, guys. Thanks for listening. Have a nice night.
See you next time.